Is glucose really bad for you? The short answer to that question is no. In fact, glucose is an essential nutrient for at least four tissues and cells, including red blood cells, the brain, kidney, medulla, and testes. Red blood cells, which deliver oxygen to various tissues for tissue respiration and remove CO2 from these tissues, are entirely dependent on glucose as their energy source. Similarly, with the exception of prolonged fasts where the brain can use ketone bodies, the brain is entirely dependent on glucose for its energy needs under most circumstances. The misconception about the bad health effects of glucose has a lot to do with elevated glucose in the bloodstream, which is associated with increased risks of certain health conditions. Elevated plasma glucose is associated with risks of obesity, hyperglycemia, insulin resistance, and eventual development of diabetes type 2. Through the actions of various hormones and input from a variety of tissues, blood glucose is maintained between 80 to 100 milligrams per deciliter. Under these conditions, all the tissue needs for glucose are fulfilled, and there are no deleterious effects of glucose on most tissues. When hormones are effective in regulating and maintaining plasma glucose between 80 and 100 milligrams per deciliter, various tissues, including red blood cells and the brain, can access plasma glucose that they absolutely need. This is especially important for red blood cells because glucose is their only energy source, and also very important for the brain during short fasts and during sleep. In fact, the liver plays a key role during sleep in restoring plasma glucose, so tissues like red blood cells and the brain can use it as their energy source. Therefore, one must not overlook the need for glucose by various tissues to sustain their energy requirements, and distinguish those tissue requirements for glucose from the risks associated with elevated blood glucose for the development of specific conditions or diseases. Although elevated plasma glucose associated with obesity, insulin resistance, and diabetes type 2, in most non-diabetics, four hormones collectively regulate blood glucose. Insulin released after a meal will promote the uptake of glucose specifically into muscle and adipose tissue, while at the same time promoting the storage of glucose in the form of glycogen in liver and muscle. These effects of insulin will ultimately reduce blood glucose after a meal. During fasting or sleep, an increase in glucagon, epinephrine, and cortisol release will promote the liver to hydrolyze stored glycogen or synthesize glucose from smaller molecules, thus restoring blood glucose to its normal levels. If you like this video, please subscribe. Thank you.